are given a chance to attend the event,
The
the
second
second International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics 2020. Honorable Rector University of Jember, Insinyur Iwan Taruna, Magister of Engineering.
Honorable Dean, Faculty of Teacher Training and Education, Professor Dr. Andes Davik, MSc, PhD, and Vice Dean, Professor Dr. Suratno, MSc. Our keynote speaker, Professor Sebastian M. Chiwaba from University of Delaware, USA, and Professor Chun Yan Chang from National Taiwan Normal University, Taiwan.
We will see the dance performance of Kebiar Barong by Sambagi Arutala Dance Studio. Kebiar Barong dance is a typical dance from Banyuwangi, East Java. For the people of Osing, Banyuwangi, Barong is symbol of the togetherness. In every ritual of the Osing community, the presence of Barong means togetherness, to ward off evil spirits. Let's enjoy.
Before we begin, I would like to inform you the agenda of today's event. First, singing the national anthem and hymn of University of Jember. Second, speech by Chairwoman of EcoSTEM, Robiatul Adawiyah, SPD, MSI. The third, speech by Chief of EcoSTEM 2020, Professor Dr. Suratno. The fourth, opening remark by Dean Faculty of Teacher Training and Education, Professor Dr. Andes Davik, MSc, PhD. The fifth, reciting prayer. 6, photo session. 7, plenary sessions. 8, awarding presents. 9, announcement. 10, closing remarks and lunch break. And the last is parallel session.
Moving right along, we will sing our national anthem, Indonesia Raya, and hymn of University of Jember. Audiences are welcome to stand up. Please be seated.
The next agenda, we will have a welcoming speech by Chairwoman of EcoSTEM, Robiatul Adawiyah, SPD, MSE. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Director of University of Jember, the Honorable the Dean and Vice Dean, Faculty of Teacher Training and Education, University of Jember, the Honorable all of the invited speakers, EcoSTEM 2020, and all of the participants of EcoSTEM that I love so much. Thank you very much for the opportunity given to me. I am, as the representative of the EcoSTEM Committee, would like to give a very high appreciation for all of the participants who give their time to join this international conference. EcoSTEM is the annual conference which is conducted by Faculty of Teacher Training and Education, University of Jember. This is the second year of EcoSTEM, and we have already published about 73 papers in the Journal of Physics Conference Series indexed by Scopus in 2019. Same as the invited speakers who came from around the world, the participant of EcoSTEM 2020 also comes from many countries, not only from Indonesia, but there are also participants from overseas, such as from Malaysia, Philippines, Vietnam, and others. We would like to welcome all of you in the International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics. We do hope that all of you can enjoy this event. As the EcoSTEM Committee representative, we would like to ask for your apologies if there were any mistake during this event. I think that's all from me. Thank you very much for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Robiatul Adawiyah, SPD, MSE.
The Honorable Professor Suratno will deliver the second welcoming speech as the Chief of the Second International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics 2020. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala asrafil anbiya'i wal mursalin. Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Allahumma sholli ala Muhammad wa ala ali Sayyidina wa maulana Muhammad. Honorable Rector University of Jember. Honorable Dean of FKIP University of Jember. Honorable Dean and Vice Dean of the University of Jember, Honorable Chairman of Lesson Study Learning Community for Tropical Studies Research Group, University of Jember. All distinguished invite speaker and participant. First of all, on behalf of the organizing committee, I am delighted to welcome you to the second International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics 2020. I am pleased to see all of you in this forum. About 1,050 participants have joined this conference. The conference is held to welcome participants from around the world with broad and diverse research interests of science, technology, engineering, and mathematics, and their application, as well as education. I'm also pleased to note that the majority of our participants come from the various universities. Naval Institute of the National University Ukraine, Tudan Mot University Vietnam, University Tunku Abdul Rahman Malaysia, Bothwit and Bayan Indonesia University. I would like to address my special to our keynote speakers, Professor Sebastian M. Sioba, University of Delaware, USA. Professor Chun Lian Chang from National Taiwan Normal University, Taiwan. Professor Chukchai Yun Yang Yong, PhD from Kun Ken University, Thailand. Professor Dr. C. Nagamani, the Gadigram Rural Institute from India. Professor David, PhD from the University of Jember, Indonesia. Professor Suratno, MSc from the University of Jember, Indonesia. And Dr. Hobli from the University of Jember, Indonesia. This is the second International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics 2020, supported by LSLC for Tropical Studies Research Group. The mission of this annual agenda is to become an annual international forum where civil society, organization, and representative, research studies, research student, academics, and researcher, scholar, scientist, teacher, and practitioners from all over the world would meet in exchange an idea to share and discuss theoretical and practical knowledge about science, technology, engineering, and mathematics in application. Furthermore, I would like to express my sense of appreciation to, first, Director of University of Jember, Bapak Dr. Insinyur Iwan Taruna, Master Engineering. Dean of FKIP of University of Jember, Professor David, PhD. And then Chairman of LLSC for Tropical Studies Research Group, who have shown their profound support in making this conference available. I believe that you will have an exciting meeting here in Jember University by online. Please use this opportunity to interact with each other, to exchange your experience and ideas for the future. Finally, I wish all the success to the conference participants, and let me once again extend my warm welcome and regards to all participants. I wish you an inspiring and enjoyable conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Dr. Suratno, MSc.
The opening remarks will be delivered by the Dean of Faculty of Teacher Training and Education, Professor Dr. Andes Davik, MSc, PhD. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Innal hamdalillah nahmaduhu wa nasta'inuhu wa na'udzu billahi min syururi anfusina may yahdihillahu fala mudhillalah wa may yudlil fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh la nabiyya ba'dah. Selamat pagi dan salam sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning, ladies and gentlemen. First of all, I would like to express my sincere appreciation to Your Excellency, Rector of the University of Jember, Bapak Dr. Iwan Taruna, who consistently support the existence of the International Conference on FKIP Universitas Jember. We provide at least 3 conferences annually, and today we have international conference, namely the second ECOLSTEAM. Secondly, I would like to extend my thanks to all the organizing committee, and as well as the Honorable Professor Sebastian, Professor Nagamani, Professor Jokchan, and also Professor Chun Yang Chang, and the others invited speaker. For today's special warm welcome to all participants who join this conference in this morning. In US, it's already evening time, so sorry for Professor Sebastian, and also thanks for my academic sister, Bong, who already communicates with Sebastian and invite him to be an invited speaker today. Ladies and gentlemen, the event of scientific forum, such as this conference, is very important. It's a part of the research literacy, which should be possessed by the faculty member of the university. In our university, we have, of course, 3 sides. The first side is teaching activities. The second one is research, doing research, and the third one is social services. As the fusion of the research is set to raise an advanced university scholar, which gains a good impact to society. I believe research not only finish in reporting document, starting from writing a proposal, doing a research in writing a document, but the main thing of the research activity is dissemination process. Dissemination process can contains the attending in scientific forum or submitting and writing a manuscript to be submitted into a journal or conference proceeding or writing a monograph or book chapter. Our university, especially this faculty, the Faculty of Teacher Training and Education, namely FKIP of the University of Jember, has got a high commitment, consistently and persistently support our faculty members to do a good research and to gain a research literacy and support them to attending a scientific forum, and finally has got a proceeding publication or journal, regular journal publication. Our faculty year to year has the bigger number of publication which already published in a journal index by Scopus or WAS, Web of Science. Of course, I, on behalf of the faculty, as a dean of this faculty, feel proud of our faculty member. But as a society and as scientists and the scholar, we not only encourage our faculty member in internal our faculty, we also encourage the teacher, the lecturer from other institution to do a good research, to have a research literacy. So therefore, now we invite a lot of scientists from all over the world, from US, from Australia, from India, from Thailand, as well as from South Korea, to share their current research, and potentially for the participant can take opportunity to have this research of interest or their research result to probably implement in Indonesia, in your institution, in your school, or in your university. So please take this opportunity to share your idea for the plenary speaker as well as for the parallel speaker, and maybe we can have a joint research or a joint paper in the future. Again, I express my sincere expression for all of you who has already joined this research, and hopefully this scientific forum will benefits to all of you. Enjoy your conference by reciting Basmala, Bismillahirrahmanirrahim. I declare this conference open for all of you.
Please give applause.
Thank you very much. Allahumma afiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. David.
The next agenda is Uttering Prayer that will be led by Dr. Hobri MPD. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala sayyidina Muhammadin asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma antas salam wa minkas salam wa alaika ya'udus salam fahayyina rabbana bis salam. Ya salam sallimna ajma'in waj'alna min ibadikas salihin. In the name of Allah subhanahu wa ta'ala, the most merciful, the most kind. Ya Allah, I beg you of all good things which pertains to this day and days hereafter. I beg you protect us from all evil which pertains to this day and days hereafter. Ya Allah, you are peace, and all peace is from you, and all peace returns to you. O Master of power and glory, in conjunction of the Second International Conference on Lesson Study of Science, Technology, Engineering, and Mathematics 2020. Guide us among those whom you guide. Grant us health and pardon among those whom you grant health and pardon. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizki wa taubatan qablal maut wa rahmatan indal maut wa maghfiratan ba'dal maut. Allahumma hawwin alaina fi sakaratil maut wan najata minan nari wal afwa indal hisab. Ya Allah, unite us in this conference and provide us with a full knowledge, with a strength and the right effort to make the appropriate actions. Ya Allah, verily we ask you for the best supplication and the best success and the best deed and the best reward. Allahumma ya qawiyyu ya aziz ya fa'alul lima yurid. Ya Allah, you are the most forgiving and one who loves forgiving. Therefore, ya Allah, forgive us in this conference and its related meeting a very pleasant and productive. Amin ya rabbal alamin. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina adzabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in walhamdulillahi rabbil alamin. Assalamu alaikum warahmatullahi wabarakatuh.
Thank you, Dr. Hobri MDD. The next agenda is a photo session. We would like you to turn on your webcam so we can see your lovely face. Please stand still and keep on smiling. The committee will take the screenshot.
This way. Keep smile.
Okay, thank you.
Welcome to the plenary speaker session. In this first plenary speaker sessions, we will have Professor Sebastian M. Sioaba from University of Delaware, USA, as the first speaker. This session will be led by David Imamyarta, SPD, MPD, as the moderator. We have 45 minutes for the first plenary sessions. David Imamyarta, time is yours.
Check. Well, Assalamualaikum warahmatullahi wabarakatuh. And good morning, ladies and gentlemen. Good morning, Professor Sebastian. Are you with us right now?
Yes, I can see you. I can hear you very well. Thank you.
Okay. Thank you so much, Professor, for being with us in this conference.
Yeah.
Well, ladies and gentlemen, now as we reach our first plenary session, allow me, my name is David Imamiarta, and I'm going to be the moderator for the first plenary session. And in this plenary session, we are going to have a talk, presentation by Professor Sebastian M. Chioba. But before we proceed with the presentation, allow me to read the CV of our first keynote speaker. So Professor Sebastian has been very interested in discrete mathematics, algebra, optimization, computer science, and probability. And his academic positions have been very remarkable. He is the professor in the University of Delaware in USA, also the associate professor at the University of Delaware in United States of America. And also he was the postdoctoral fellow at the University of Toronto, Canada. He achieved his PhD in mathematics at Queen's University at Kingston, Ontario, Canada in 2005. And he obtained the master's degree in science of mathematics at the same university, Queen's University at Kingston, Ontario, Canada. Professor Sebastian has also involved in several editorial works, such as the editorial board in linear algebra and its applications, guest editors on special issue, especially on discrete mathematics, dedicated to the algebraic and extremal graph theory. In addition, he has also written several book chapters, such as some applications of the eigenvalues of graphs, and also graphs and expanders. Also, he has published numerous papers on diverse journals, such as the Electronic Journal of Combinatorics, Journal of Combinatorial Theory, and also Experimental Mathematics. And then also he has obtained numerous prestigious awards, honors, and also grants, some of which include the nomination for excellence in research in the College of Arts and Science at the University of Delaware, and then the nomination for excellence in teaching in the College of Arts and Science at the University of Delaware. Last one but not the least, he has also attended numerous talks throughout the years. Some of the talks to which he has attended is the Baltimore Number Theory and Combinatorics Seminar via Zoom, and also Waterloo Algebraic Graph Theory Seminar, also via Zoom. Okay, well, Professor Sebastian, we have 1 hour to cover the whole plenary session, but we have 45 minutes to do the presentation. The time is yours, Professor.
Okay, thank you very much. So I'm very honored to be invited to give a talk in your conference. And we know we're living difficult times with the COVID pandemic and so on, but I think it's very nice that we can be together from different parts of the world and celebrate the thing that we like most, in this case, mathematics, the research and the teaching of mathematics. It's a thing that unites us regardless of our nationality and so on. So I'm originally from Romania. So I did my undergraduate in Romania, and then I went to Canada for my PhD and master, and then I went to United States for my for my postdoctoral work, and now for my position. And I enjoy discrete mathematics, my area of research, but I also enjoy teaching. So I will give you a talk which maybe for those of you who are interested in teaching, and all of us who are teaching mathematics, we know that it's not the easiest thing, because these days nobody has that much patience to sit and think and work through the problems. And everyone tells our students that mathematics is hard and, it's okay if they're not good at it and so on. So I will tell you some problems that perhaps that are fairly simple to state, but you can perhaps use them with your students in classrooms and try to win the hearts and the minds of your students and make them curious. And once you make the students curious, the job is a lot easier because they can push things from there. So I will share my screen, and I have some slides that I prepared. So let's see how this works. Okay. Let me see. Yeah, can everybody see my screen now?
Yes, it's very clear, Professor. Thank you.
Okay, thank you. So I will give you a brief introduction to my area of research, which is graph theory and combinatorics. And I do this type of talks for our students, and I try to put like cute pictures to have the students, to remind them somehow in the back of their minds when they remember this talk that what I talked about was very nice and cute and it wasn't scary at all, So that's why I put the pictures there. So let me see, I'll click here. Okay, so graph theory is the abstract, it's the, it's the mathematical study of networks, essentially. So graph theory, it's said to be, it has started with the work of Leonhard Euler in the 1700s. So Euler was a mathematician at the court of in Königsberg, and he was asked this question. You see on the picture on the left, there are 7 red segments. Those are bridges, and the blue is a river. So the question that was asked to Euler was, can you go through every bridge exactly once and come back to where you started? Now, if you look at the picture, or if you think about it initially, it seems like this is a problem about geometry, but Euler realized that it doesn't matter how it's a different type of geometry. It's not a geometry of measurement. It doesn't matter how deep the river is, or how big the land is, or how large are the bridges and so on. All it matters is how the pieces of land are connected by the bridges. So it's a geometry of position. That's how he called it. So he didn't draw the picture that I have here on the right. This was done much later, but the way we kind of, in our modern times, we interpret, we can make an abstract model of this picture is to use a dot for the north part of, for this land piece, to use another dot for the piece that's here in surrounded by water, another dot for this piece here on the right, and another dot here in the south. And all it matters is how many, if they're connected by a bridge, and if so, by how many bridges. So for example, the part here on the top and the part here in the middle, they're connected by 2 bridges. So that's why we draw two dots, two lines, 2 curves here. And similarly, the part on the top, and the part at the bottom, they're not connected by any bridge, so there's no connection. So that's a way you can basically draw this diagram that anybody can do it. Any kid can do it in kindergarten or primary school and so on. And now the question is, can we start at one of these dots, go through every line exactly once, and come back to where we started? And I assume like many of us have tried to do that with different pictures, with different configurations. And in the case of this problem, what Euler argued is that if it was possible for you to go through every bridge exactly once and come back to where you started, then the number of connections, the number of bridges at every point would have to be even. And that is because if let's say we start at this point here on the left, if you walk up to the point on the top, you go on one bridge and you cannot use that bridge again. So you have to go out on a different bridge. So every time you go through a node, you're going to use two bridges which come from that node. And in order for you to go through every bridge exactly once and come back where you started, the number at each position, at each node would have to be even, the number of connections. And it turns out that's basically a necessary and sufficient condition. So you can go through every edge exactly once, if and only if the number of connections at every dot is even. In this case, it's not true because the vertex on the top has 3 connections, which is not even. So it's impossible to do such a tour. So that was Euler, and that started with a very nice theorem. On the top, it's a stamp from the former Democratic Republic of Germany, with again a different contribution of Euler, the formula connecting the number of vertices, the number of edges, and the number of faces of a polyhedron, and that's the icosahedron there on the top, the dodecahedron. I'm sorry. Okay, so now what can you do with students? So in some of the classes that I taught, I can do I did the following. There is an app, and you can find it on, if you have an app, iPhone, or if you have a different phone, you can find them online, and it's a free app, and it's called One Touch Drawing. And basically in this One Touch Drawing, the game is you have a configuration, like, the configurations can get quite complicated, and you are asked to go through every connection exactly once. And in, like, for example, for this picture here on the bottom left, it's not you cannot go through every edge once and come back to where you started, because the nodes at the bottom, you see there are 2 nodes that have odd degree. They have degree 3. They have 3 connections. So there is actually more math behind it, that in that situation, you can only go from one of these nodes and end up at the other node. If all the nodes have even degree, you can just start at the node and come back to where you started by going through that. So the students actually respond very well, and sometimes I give them some bonus points in my class and so on, and you get them curious about these things. And that's, for me, that's the best thing about doing this job, teaching mathematics, when the students are curious and they get interested and so on. So this is one thing that anybody can do, and you can, you can just give them the app and have them play with it and then explain how it works. Another thing that I did, it's something related, you change the problem a little bit. And it's this kind of famous, the traveling salesman problem, which, you have some kind of network, and, you have a salesman. Well, that's the story. You have to go now. You have to start at a node, and you have to go through every node exactly once and come back to where you started. So you don't have to go through every edge exactly once. You just have to go through every node. But whenever you traverse an edge, that edge has a cost. So maybe it's the gas that you pay for driving, or whatever, the accommodation, I don't know. But there is a cost to it. So the problem is, how do you start at some point, go through every node exactly once and come back to where you started with a minimum cost? Okay, so that's the question. Like a natural cost that would be, if I drew this in a plane, is just the distance between the points. So this is obviously, if you want to visit your relatives, you start at a point, and you want to visit your friends and relatives and other friends and so on, and you want to come back home, you'll be interested in finding out what is the shortest path, the shortest way, the most economical way for you to do that. So this is a famous problem, the traveling salesman problem. And it's closely related to what is called Hamiltonian cycle problem, which is the problem, if you are in a network, can you go through every node exactly once and come back to where you started? So it's slightly different. It's slightly different from the problem before with going through every edge. You have to go through every node, and this problem is actually more difficult. Okay, so here's an example, and this was known for quite a few years, and I'll give you the references in a little bit. So this is, it's not the 50 states tours, because you have Alaska and you have Hawaii, which are it's difficult to drive there. But you can do like this tour of the state capitals. So each of these red dots is the capital of one of American states, and this seems to be like the shortest tour that that goes through. So here the cost of one of these edges is just the distance between them. Okay, so obviously you have like far apart edges, versus here on the East Coast where I live, things are fairly close, like around Philadelphia, New York, and so on. So 48 states it can be done, and this was done a while ago. And actually it can be done more than that. They've done like these crazy, amazing tours that you can do like 13,500 cities tour. And there are like very, very smart way of doing this. I'm not going to go into that detail. But one thing that you should realize is that in this, has to be pointed out to the students when discussing these problems, that even, for example, even for the case of 48 states tour, the number of possibilities is just huge. It's a factorial number, okay? So this grows, even like higher than exponential. So you cannot do a brute force. So you have to come up with something smarter. And there are various algorithms. There's a famous algorithm called Christofides algorithm, which builds a spanning tree first and so on. And then, but now they have like even more sophisticated algorithms and so on. So this is, it's quite interesting. Now, what can you do with the students? So here's some resources. So if you Google traveling salesman problem and you go to the University of Waterloo in Canada, it's a very strong university. It has a department of combinatorics and optimization, and they have very strong people there. And you will find this webpage with an amazing resources with many, if people are interested in programming, you can find things in Python. You see here at the bottom, you can do Pokemon Go tours. I have 2 children myself, 2 boys, and they love Pokemon. So they go do Pokemon Go tours. Somebody's interested in other tours, like visit the historic sites in the US, you see it goes to like different numbers, like huge. And it's a wealth of information, and it's not something that can be absorbed in one day. This is a big area of research, but you can get students into it, and there are more things that you can do. So this is one game that actually my kids like very much. So you can download something. This is a very nice, amazing app actually done by Bill Cook. And this is called Concord TSP. So again, it's free. You can download it. I have it on my phone, and my kids ask me to play it. So there is a game. There's a challenge that you can play there. The app gives you some points on the plane on your screen, and the challenge is, how do you create a tour that goes through every one of them and come back to where you started with the shortest distance? Now, it measures how good you are by giving you the percentage that you're far off. So if you get optimal tour, it will tell you that this is 0%. So you basically got the best tour. But sometimes you don't get good, so you're like within 5% and so on. So the challenge that we have with my, like I was playing with my kids, my wife, it was to do something with like, you can get pretty good at it. You start with 5-10 points, you go to 20 points. And my challenge with my wife and kids, if you get 50 points, to get a 0%, to get it well. And it's quite tricky to do it, but it stimulates, it makes you think, why do the tour look so kind of concave? Why is the shape so much? So it's something that I think it attracts a curious mind, like the students that are curious, and it makes them interesting in the subject. So this is something that like I said, my children are very young, like age 10 and 7.5, and they like playing this because you don't need to, it doesn't need any sophisticated mathematics, just your kind of common sense, how to join some points. So this is about drawing, connecting edges and connecting points. I'm going to switch gear a little bit and tell you about something that when I first saw, I thought it's kind of crazy. So let's say, we're playing a game and I'm, you can pick a number between 0 and 15 and I'm trying to guess the number, okay? I can always guess the number if I'm asking you something like, 14 questions or 15 questions. Is your number 0 or not? You say yes or no, and then I move on to the second. You can do something clever with like, okay, is your number bigger than the middle or not, and so on. But, here's the trick. Now, I'm going to give you even more freedom. I can let you lie once. So I'm going to, basically, I can ask you these 7 questions. They seem kind of weird, and you will see where they come from. And you're allowed to lie once, and I can still figure out, once you give me your answers, I can figure out what the number was and how the idea. So I'm not going to play because there are 170 participants, but this one, it's you can find it in many places. Like Peter Cameron has he has some webpage with these things. But how does it work? Like what's the idea? So here's the idea. Basically, if you write down for each number, the answer to these questions. So in this table, I have the numbers from 0 to 15. I have them labeled by the rows. And the questions, I have 7 questions. They are these 7 columns, okay? So if I get the number 0, what's the answer to the first question? Is 0 the number 8 or greater? The answer is no, and I use a 0 for no. And then is the number 0 in this set? No, I use a 0. Is the number in this set? No, I use a 0, and so on. So you understand what I'm talking. Is it odd? It's no, and so on. So what you get here, you get this matrix, which is 16 by 7, which has zeros and ones. But this is a special matrix. This is a special matrix in the sense that if you take any two rows, they differ by at least 3 positions. If you get, for example, if you take the first 2 rows, they differ in 4 positions. If I take the row 0 and row 2, they differ in these 3 positions. Any 2 rows, and I mean, there is a reason for that. I mean, there's something hiding here. If you have nothing to do, you can check any 2 rows, but you can prove it in a different way. But any 2 rows, they differ in at least 3 positions. So what happens is that that's exactly what I just said. So if you tell me one lie, then your response, like the response that you give me to these 7 questions, is going to be a 0, 1 vector. And I get your answer, like the 0, 1 vector. And even if you tell me one lie, because of this property of everybody being at 3 apart, your vector is going to be the closest to exactly one of these rows. So I can tell you immediately which one is a number that you guess and where you actually lied to me. So this is an example of a mathematical structure which is called a Hamming code. It's the simplest code. It's the kind, maybe not the most famous one of the most famous ones in coding theory. And sometimes coding theory and cryptography, they get mixed up together. Coding theory, what it deals with sequences of creating these kind of sequences of words that are far apart from each other, that cannot be confused to each other. And why is that important? That's important when you transmit information. Like, for example, when you send pictures from Mars back to Earth, there's a lot of noise. So many of the bits that you send can change. So then how could you change things that will still be, how do you send reliably information from Mars, let's say? So then the game is to add redundancy to whatever you're sending. So coding theory, it's this type of, plays a very important role in this type of problem. Now this is a little bit more advanced, so this, you know, you can play these things for maybe, you know, it's not a kindergarten game and so on, but you know, nevertheless, I think it's very interesting, and you know, it you know, you need some linear algebra, so maybe high school or undergraduate and so on. Okay. Now, other things that can be done, you know, you can. This is at even kindergarten level and stuff. You know, this is a famous theorem, maybe one of the most famous theorems in graph theory, which is that every map can be colored with 4 colors. So this is a map of the United States, you know, covered with 4 colors, and you can, you know, you can come up with all kinds of maps that you can ask the kids to color with this, you know, such that no two adjacent regions get the same color. Okay, so even you know, you can color the world with you know, like North America is easy, you know, South America, okay, fairly easy, you know, yeah, you can, you know, Europe is harder, but anyway, any map you can color it with 4 colors, and this is again something that you know, you can pitch it even at kindergarten level and so on, and you can make the students curious. Of course, this gets more complicated because coloring, it's actually a non-trivial problem, you know, to if I give you a network or like some kind of map, to color it with the smallest number of color, you know, it's not a trivial business. But you know, nevertheless, this again, this is a problem that gives you easy entrance into maybe the heart and the minds of the students, you know, just coloring the graph, the network. Okay. Now another problem. So this is, let's say, a perfect matching. So how do you find a perfect matching? So let's say you have I'll change the problem here. Then you have a set of men and a set of women, and this is maybe the compatibilities between them and so on. And so how do you match each man with a woman that maybe they're compatible? So it's not so obvious, you know, maybe you match Adam with Anne, but then, you know, you cannot match Adam with Beth. But can you, you know, how can this be done? And in this situation, yeah, there is a way with, you know, with the red, you know, so this is the red edges find what is called a matching. And finding matchings, so a matching is a collection of this type of edges, you know, with one with no person being involved in 2 matchings and so on, in 2 edges, so on. This is again a serious area of research in graph theory, in optimization, computer science, and so on. But it's even more than that. So this is Lloyd Shapley. So in 2012, he got Nobel Prize in economics, and he got Nobel Prize joint with Alvin Roth. I'll mention this in a second, for the theory of stable allocations. Now, as you well know, there is no Nobel Prize in mathematics. There's Abel Prize now and the Fields Medal and so on. But essentially, Lloyd Shapley was a mathematician, and he did something. So I'll tell you in a second what he did. So he was born in He was born in 1923. He got a Bronze Star for doing he deciphered some Soviet code. He went to Princeton for his PhD with Albert Tucker, and then he was at Rand Corporation in UCLA. Now, this is the citation from the Nobel Prize. So, they give you a citation. And basically, I highlighted, this is my highlighting, like he used what is called cooperative game theory. Now, if you've seen the movie A Beautiful Mind with John Nash and so on, so in that movie, John Nash, he was involved in doing non-cooperative game theory, everybody on their own and so on. But here, Lloyd Shapley was, on the father what is called cooperative game theory, to compare different matching methods. And he studied, he basically ensured that matching is stable. I'll give you the details in a second. But they tell them here, in a sense, that 2 agents cannot be found which prefer each other over their current counterparts. That's what stable is. And Shapley and his colleagues developed this algorithm, Gale-Shapley algorithm, that always ensure stable matching. So there are other issues around it, but for now, it's cooperative game theory, stable matchings, and Gale-Shapley algorithm. So if you Google Lloyd-Shapley on Scholar Google, you get this paper this is the paper that they mentioned, Gale and Shapley, which is cited. This was a while ago when I did this, probably 2019 or 18, was cited 2,400 times, okay? The amazing thing is that this paper appears in American Mathematical Monthly, which is an amazing journal. It's a very nice journal, but it's dedicated to mathematics that is elementary. So elementary, it doesn't mean simple. It can be quite subtle and difficult, but it means that elementary is, you can understand it with no special background. You don't need to, learn so many prerequisites. Somebody with a good high school education or early undergraduate should be able to understand what's going on. And this paper is a short paper, it's like 7 or 8 pages, and it's very well written. And some of my students have read it, my undergraduates, and they like it very much. So you can give this to your students to read it. It's a very nice paper. Now, what does it do? So what do they do in this paper? So this was a paper by college admission and stability of marriage. So as the title says, they consider two scenarios. So the college admission, this is the scenario in United States. So you have applicants, which are students, and you have colleges, and each student, they rank the colleges that they want to go to, whatever ranking, sometimes is personal, sometimes is objective. Obviously it's, most of the time subjective. And then each college ranks the applicants and has a student quota, so they cannot beat everybody. Now, if you match each student to a college and so on, this assignment is unstable if you can find 2 students, let's say Alice and Bob, which are assigned to 2 colleges, let's say Harvard and Yale. So let's say Alice is assigned to Harvard and Bob is assigned to Yale, but Alice and Yale like each other better than what they have now. So unstable means that Alice, she was assigned to Harvard, but she likes Yale, prefers Yale better to Harvard. And Yale was assigned with Bob, but Yale prefers Alice to Bob, okay? So this is what unstable is, and an assignment is called stable if it's not unstable, basically. So you don't want to have any of these pairs, essentially. Now, how does the stability of marriage? It's pretty much similar. Now, you have the same number of men and women, and each person provides a ranking of the members of the opposite sex. So every man has a preferences for the woman, first preference, second, and so on, and preference. And every woman has the same, like a preference for the man. And a set of marriages is unstable if there exists a man and a woman who are not married to each other, but they prefer each other to their actually current mates. So again, the question is, for any pattern of references, how is there a stable matching? And if it is, how do you find it? So that's exactly what Gale and Shapley did. And this is how they did. And this is an algorithm, and it goes in rounds, and it's very simple. So it depends if the men do the proposal versus if the women do the proposal. The matching that you obtain may be different, but still in each situation, the matching is going to be stable. So let's say with the men proposing. So in each round, every man not engaged proposes to his favorite woman that has not rejected him yet, essentially. Every woman picks her favorite among her new proposals, and the men she's currently engaged to, and the other men are permanently rejected her. And then all rejected men cross off their list of women. It seems like maybe it's not as simple as I stated, but let's do an example to see how it works. So in this picture, the men are alpha, beta, gamma, delta, and the women are A, B, C, D. And in this entry, if I read the row of alpha, the first entry in each position gives me the ranking, the preferences of alpha. So alpha prefers A. A is the first, B is the second, C is the third, D is the fourth. The same thing, beta also prefers A first, B second, 3 and 4. Now, for the woman, the preferences of the woman are the second digits. So if you look at capital A here, she actually prefers gamma best, delta second, alpha third, and beta fourth. And C prefers alpha first, beta second. So I hope it's clear. It's basically the first coordinate, you read it row by row, and it gives you the men's preference. The second coordinate, you go column by column, and it gives you the women preferences. Okay. And so in the first round, every man proposes to the top woman on their list. So that's what happens. So alpha, A is the first, so it proposes to A. Beta, also A is the first. Gamma, B is their first pick. And delta proposes to C. Now it's the turn of the women. So, the only woman that's doing anything is going to be A. A has received proposals from alpha and beta and looks what are her rankings. So beta was fourth and alpha was third. So A is gonna reject beta, and that's the X here. It means that A rejected beta. Now it goes back to the men. Beta has been rejected by the first choice. Is gonna move to the second choice, which is B. So I'm gonna go to so this was the initial configuration. This is the first proposal. This is A rejecting beta. And now beta is gonna propose to B. B gets two proposals from beta and gamma. If you look at B here, it's got 3 and 4. So now B is gonna reject gamma. And now gamma proposes. So you understand how it works, but this is, it's not super complicated. And you can actually, do these things by hand, or if students are good at programming, you can program these things. So I'm not gonna go through the whole details, but essentially it goes on for a little bit. So I picked the one that on 4x4 has the longest. This is actually an example, I think, from their paper. And it goes on and on and on. Let me see. Here, it finishes at the end. It goes in many rounds. And basically alpha gets paired up with C, which is not their first choice, is their third choice. Beta gets paired up with D, their last choice. Gamma gets paired up with A, third choice. Delta gets paired up with third choice. But it's a stable matching. So, that's all we care. So there's a huge research about these things, Gale-Shapley algorithm. And, when they wrote this paper in 1962, in the paper, I found funny. It's kind of ironic in some sense, you'll see in a second, that they somehow, it's not apology, but they say that, we studied this math problem and we kind of make this assumption and we moved away from the original college admission problem and we abandoned reality altogether and we entered the world of mathematical make-believe, that's sometimes what we do. And, the people who are practical minded may ask whether any contribution has been made toward any solution. It's kind of like our students are asking, why do we need to do this? Why is this useful and so on? And they kind of didn't know, but they said, we believe that the ideas should be useful and so on. But it turns out that maybe they weren't aware of it, but this was actually used, and it's used for what is called the National Resident Matching Program in US, in which the residents, after they finish medical school and in their resident program, they rank the hospitals that they want to work, and the hospitals rank the residents. And this was done maybe before Gale and Shapley, that actually this algorithm was used in matching the residents with the hospitals. Because if you didn't, like you see here also, like if the doctors make offers, you get some outcome. If the hospitals get offers, you get maybe a slightly different outcome. Without this type of procedure, it became very complicated because people would wait. Maybe they get an offer, but they wait. It's not their best offer, so then they delay giving answers to wait for a better offer, and so on. So this was the kind of the safe choice. So it's very interesting. And now this thing has been used to many things. So this Nobel Prize was given to Lloyd Shapley and Alvin Roth for the theory of stable outlook and for the practice of market design. So Alvin Roth is a brilliant economist who has used this type of ideas in even like improving kidney donation. Like, maybe you have a family in which a member of the family needs a kidney, and someone in the family wants to donate a kidney, but they're not compatible for some reason. And so then what he would find some other people. So the member of the family would donate to kidneys somewhere else, and then another kidney would come to the member of the family. So this kind of chains of donation. And in other places, like matching students with the high schools that they go to and so on, there are all kinds of applications. So again, starting from these very kind of combinatorial ideas about stable matchings and so on. So yeah, this is kind of important work. Now, it's getting, maybe it's morning. Yeah, it's morning in Indonesia. So, in case you're hungry, you want to flip some pancakes. So this is another problem that I find fascinating. So this is a description, and I'll give you the link in a second. You can Google it. There is a nice webpage, Data Genetics, because actually this pancake stuff has actually connection with molecular biology and genetics. So the description is a little bit here, but basically you have a stack of pancakes. These are pancakes, and they don't have all the same size. And you want to rearrange them such that the biggest one is at the bottom and the smallest one is at the top. So in decreasing size as you go up. But the rule is the only way you can rearrange them is by, so this is what you want. You want the pancakes to be in this shape. You don't want them to be this. But so the person who's cooking the pancakes, they don't pay attention, so they put them to you like this. And now what are the operations that are permitted? You can only put a spatula. This is red. The red thing is a spatula here. You put it any point you want. So here it's below the top three, and then you flip it. So you take the spatula and then you flip it and you put them back here. So clearly it doesn't look closer to this shape. You did the wrong move. So the question is, which type of pancake arrangement is going to take you the longest to flip, in how many moves, So here's the beginning. If you have one pancake, you just eat it, you're lucky. If you have two pancakes, you're also lucky, because if it's already arranged, you do nothing. If it's in this form, you just do one flip. You put the spatula at the bottom and you flip it, and you got them in the right order. Now, what do you do with three pancakes? So the three pancakes, you can think of it in terms of permutations of numbers. So one is at the top, two is in the middle, and three is at the bottom. So it's kind of like the way the numbers are arranged. One is less than two, less than three. So this arrangement is two is at the top, one in the middle, three is at the top, one in the middle, two, and so on. You have 6, which is 3 factorial permutations of the pancakes. Now, if your pancakes come in this form, you're done, nothing to do. If they come in this form, 2, 1, 3, you do one flip and you're done, and so on. This configuration 1, 3, 2 requires you 3 flips. You see, like you have to flip it this way, you get, and so on. So what happens when you have more pancakes? And so essentially you can encode what's going on. This is for 4. You can encode the possible pancake arrangements by permutations, like 1, 2, 3, 4. And 1, 2, 3, 4, I mean, this is where you want to get to, what are the closest to 1, 2, 3, 4? They're the ones that you can get to 1, 2, 3, 4 in one flip. And there are exactly 3 of them. It's like if you flip 1 and 2, you get 1, 2, 3, 4. If you flip 3, 2, 1, you get 1, 2, 3, 4. And if you flip the whole pancake, you get this. And this is just a part of the picture. You see, like there are other configurations. And this is how it looks actually. This is called a pancake graph. It's a pancake network. And you have 4 factorial, which is 24 pancakes, 24 arrangements. And basically, you are trying to figure out from which, from which configuration is the farthest away from 1, 2, 3, 4. So for example, 2, 1, 4, 3, it looks like I can get there in 3 steps, but can I get there in quicker? I don't know. So anyway, so basically what you're looking for is what is called a diameter. How quickly can you get from 1 point to 1, 2, 3, 4? And it's a very interesting problem. And if you go, for example, on the online encyclopedia of integer sequences, there is this sequence 0.5 and so on. And this gives you this number of the shortest number of flipping pancake, it gives you this diameter of these pancake graphs for various values of the number of pancakes. So 3, it was for 3 pancakes. So you have 1, you have 0 moves. For 2, excuse me, you can have 1 move. And for 3, you have 3 moves. For 4, it turns out to be 4. 5 is 5, but then it changes. There are these numbers. And these are the only numbers that I know for sure. Like, I think it goes only up to 19. Because, 19 factorial and so on, they're very large numbers. So they're very difficult to figure out. Now, this is a serious stuff because the actual number in general of this diameter of the pancakes is not known for general n. So what I wrote in red, so this diameter, is between 5n over 3 and 17n over 16. And these in red were proved by Gates and Papadimitriou. So Gates is actually Bill Gates, who is the president of Microsoft. He was an undergraduate student, and this is his I think, research paper on flipping pancakes. This was done in 1979. And then the bounds were improved a little bit. Like, look at the improvement in the green lower bound. It got to 1.07 essentially times n. I'm sorry, this is times n. And then the upper bound was pushed a little bit to 1.64. But there's a huge gap between these values, and we don't know for general n what's the value of this diameter. And this has variations. You can talk about burnt pancakes and so on. And burnt pancakes have application. They are very important into like this data genetics and so on. So it gets to serious mathematics. Now, what I wanted to show you, there are, and I can send you this information. Maybe I'll post it in the chat. There are web pages in which you can play these games with flipping pancakes and so on. So you can get the kids to play this and discover things for themselves. Why does it work this way and it doesn't work that way? And I think it's useful for students to try things on their own and so on. So that can be done with this web pages. I'll put them on the chat. Graph theory, it also appears in movies. So you've seen maybe the movie Good Will Hunting. He's about this janitor boy who is a genius, and here he's drawing trees and so on. And actually, the math problems that they put are actually not that hard. I mean, the adjacency matrix of A. This, I use it with my students, with my undergraduate students. This is a very simple, it's a 4x4 matrix. It's very easy. The matrix, given the number of 3-step walks, you just take this matrix and you raise it to the power 3. That's a nice thing. Now here 3 and 4 they're a little bit more complicated, but once you can teach them to undergraduate student what's a generating function and so on for walks and so on. So, but you can kind of make dispel the mystery of this stuff about what they put in the movie and so on. Sometimes it's not so hard and so on. So yeah, I think that's all I have for the talk. Again, I will stop here, and I thank you very much for your attention. And again, it's been an honor and a privilege to be invited to your talk. And again, thank you very much.
Well, thank you so much, Professor Sebastian, for such a wonderful presentation.
Thank you.
And well, again, ladies and gentlemen, we will now go on with the question and answer session. So if you have any questions or comments to what is presented, you may ask directly via Zoom, or you can write your questions in the chat box. We still have like 40 minutes to cover the whole discussion.
Okay.
Atau mungkin Bapak Ibu bisa menulis pertanyaannya langsung di chat box dengan Bahasa Indonesia. Kemudian nanti kami akan mencoba menerjemahkan kepada Profesor Sebastian. Well, Professor Sebastian, I think we have one question from the audience. The question is related to the tips and also strategies in teaching graph theory to undergraduate students. So in our university context, we also have basic mathematics for freshmen or new students. And in some parts of the course, students also learn some concepts of graph theory. Could you please give us some brief overview on simple tips and strategies to teach graph theory, especially to novice learners?
Yeah, I think, what I do here is I teach, you start with these simple problems like the bridges problem, for example, and that's something that is very simple for the students. Oh, I'm sorry. I have dogs. Just 1 second.
It's okay.
Yeah, I'm sorry. It's night here, and the dogs are barking at the outside. 1 second. Yeah, so I mean, you can start with graph theory. Is in some sense it's easy because it's more approachable. You can connect it to networks, to all this social stuff that people use these days, Facebook and so on. You can basically tell them that it models those things. And if you want to do it in a formal way, you can use like examples like I mentioned. I start with the bridges, and then I make them do this. They play with this app a little bit with this one-touch drawing, and I'm happy if they understand how to do it and so on. And then you kind of move to the next thing. So one thing I did is how if I'm given some degrees, how do you build a graph with those degrees? Those are something also very, very simple and so on. There are some theorems in graph theory like that, and they seem to participate quite well at these problems. Now it depends on how much time you have for your work. If you have we have a course, Introduction to Proof, here, in which we try to show a little bit of everything, so you don't have much time to do just graph theory. But if you have a course specifically in graph theory, then you can do more things. And you can maybe connect graph theory to linear algebra, talk about matrices, like this thing that I was showing you with Good Will Hunting. What is the number of walks? It's just the power of a matrix. And then there are many things that you can try to do that way. Okay. So I hope that answer your questions. I mean, yeah.
Okay, well, thank you so much, Professor Sebastian. That's a very inspiring ideas on how to teach graph theories on freshmen. Well, do we have one or two more questions from the audience?
Professor Sebastian, I'm Davik.
Thank you very much.
Thank you to share your idea in this conference. I just wonder if you could tell me, do you teach a graph theory in a school level in US?
Yeah, I mean, if I teach it, or what do you mean?
I mean, in the school level, the teacher teach also graph theory there. In our school, we have a combinatorics, but not graph theory.
Yeah, I mean, technically, we have what is called discrete mathematics course, and for example, it depends a lot on the instructor. Like the instructor have a little bit of freedom to choose what there is a syllabus, but there is a little bit of room for trying things. For example, I'm teaching right now, this semester, I'm teaching a graduate course. So I have mostly PhD students and so on. And this is the first course that they will get at the graduate level. And we do a bit of both. I do some graph theory and I do some counting and, enumerative combinatorics and so on. So for me, I want to put them into both. But in different, we have a second course in the spring in which I will do mostly graph theory and so on, and algebraic graph theory and so on. But yeah, so we do a little bit at the beginning just so that they know. Yeah. And I don't know, at the high school level and the schools in the United States, I don't know if they call it finite math. They have such thing called finite math, in which they do things like maybe probabilities, like if I red balls and blue balls, what's the probability that I, like binomial coefficients and so on.
Yes. Binomial expansion as well, yeah.
Exactly. And I did something similar in Romania, but I think what is very important is, the teachers are very important. The teachers are the most important in these situations, because if the teacher are passionate and they know more about the subject, not just what they have to teach, if they know more stories about it, then the students will feel it, and they will be,
Yes.
they will be curious about it, and so on.
About it, yeah.
So that's a very important. Teachers are the most important for the future of the kids, and having them know more, like kind of expand their knowledge of mathematics in terms of technical things, but also in terms of stories or things that you can basically tell the student and make them curious and interested. It's very useful.
We ever have an Indonesian Teacher Association meeting, and I propose to include graph theory in combinatorics subject course in a high school level, but they don't want to include this one. Otherwise, I believe there are a lot of combinatorial cases if they can include the graph theory and the combinatory in the school level. Yeah. In
Yes.
university, of course, we have a discrete mathematics and graph theory and even application of graph theory, something like that. Yeah.
Yeah. I mean, here it's a lot of emphasis is on calculus. Like all the students. Yeah. In high school, they have to take some university credits, some college credits of calculus, this and calculus. But the calculus, when they take calculus, it's mostly based on memorization.
Yeah,
And, it's basically you close your eyes and you say, what's the derivative of, quotient rule or product rule? Yeah, and you just recite something that you learned by, just mechanically. You don't even know how it, where it goes for, like a limit and so on.
Yes.
And it doesn't improve the critical skills or the analysis for the student. Like the discrete mathematics has this advantage that you don't have to talk about epsilons and deltas. You can get to it fairly quickly, and you can start counting, and you can start drawing dots on the line. And all you want the children is to pay attention and to make inferences. I see this picture here. That means that this represents something. So just to make these connections between them and to build on that, because at the end, what is mathematics? We just notice something, how to go from point A to point B, and then from point B to point C, and we make these connections. And they need to get used to that. And this is the easiest way that they can get into the game, just by playing with numbers and playing with concrete things. So yeah, that's my opinion.
It's very nice talk. Very nice talk. I appreciate that.
Thank you very much.
Hopefully, we can have a joint paper or joint research in the future.
I hope so too. Thank you very much.
Sebastian. Thank you.
Thank you.
Give my regard. Thank you.
Okay, thank you so much, Professor, for such a wonderful answers and also explanations on graph theory. Well, it seems to me that we still have some more questions, but unfortunately the time is over. But before we end up the first plenary talk, allow me to read the conclusion of our first discussion. So in teaching graph theory, it is always important to engage students right from the start of the lesson. And what is more important, also encourage the students' discussion and critical thinking throughout the sessions. And in today's teaching, it is always remarkable and empowering to use apps, technology of any kinds to empower students' learning process and also learning outcomes. And as we have seen from the presentation by Professor Sebastian, graph theory has lots of benefits, both within the classroom context and also beyond classroom context, like in interpretation and also health, for example. So it does offer a lot to human life. And last one but not the least, for teachers who shoulder the most important roles in the kids' future, encouraging teachers to be very knowledgeable about teaching, about the subject matter, and also social life is going to be very key to successful education, especially in the context of 21st century education. Well, Professor Sebastian, we would like to thank you so much for being here and presenting your material. It is a real honor to have you in our conference today. So thank you so much. Let's give a big applause to Professor Sebastian.
Thank you very much. Thank you.
Well, I am now passing the floor back to the Master of Ceremony.
Check.
Thank you very much for Professor Sebastian M. Chiwaba. The next agenda is awarding presents. It will be given to Prof. Sebastian M. Chiwaba, represented by Professor Suratno. We would like to invite Mrs. Robiatul Adawiyah, SPD MSE, as chairwoman to give token of appreciation for Professor Sebastian M. Chiwaba. Please welcome.
Please give applause.
Thank you very much. Thank you very much.
All right. The second plenary speaker sessions, we will have Professor Chunyan Chang from National Taiwan Normal University, Taiwan, as the second speaker. This session will be led by David Imam-Yarta, SPD MPD, as the moderator. We have 45 minutes for the first plenary sessions. David Imam-Yarta, time is yours.
Well, thank you. Right. Good morning, Professor Chang. Can you hear my voice?
Yes, very well.
So, okay, thank you so much for being here, Professor. It's been a long time.
Yes, yes.
Okay, so how are you today?
Yeah, very good.
Okay.
How's everything in Jember?
Everything is good here. Everything is wonderful. Well, we're still dealing with the
Ah.
pandemic, but still everything is under control. And we do hope that everything is okay with you and the whole family in Taiwan.
Thank you so much. It's very good to see all my old friends in Jember.
Yes, thank you so much.
Online.
Well, I see that's a very wonderful batik you're wearing right now. Okay, well, ladies and gentlemen, we will now go on with the second plenary session, and our second keynote speaker is Professor Chunyan Chang. Again, before we proceed with the presentation, allow me to read the curriculum vitae of our keynote speaker. Professor Chunyan Chang is a science education scholar in Taiwan. Currently, he is serving as at the National Taiwan Normal University, or NTNU, as the chair professor, and also director of Science Education Center at NTNU. He is also the professor of the Graduate Institute of Science Education and Department of Earth Sciences. And over the past few years, he has been a visiting professor at the Taipei Medical University. From the period of 2007 up to 2009, he served as the discipline coordinator from the Department of International Cooperation and Science Education at the Ministry of Science Technology in Taiwan. And he is also a long-standing reviewer of research projects. Dr. Chang, or Professor Chang, now is the editor-in-chief of the Eurasia Journal of Mathematics, Science, and Technology Education. And he's also serving as the co-editor of International Journal of Educational Methodology. He is also on the editorial board of 3 SSCI level journals, such as studies in science education, learning, media and technology, and Journal of Science, Education, and Technology. Professor Chang has authored and co-authored more than 140 articles, from which more than 100 articles are indexed in the Science or Social Science Citation Index database. And then allow me to read the academic background of our second keynote speaker. His dissertation in 1996 was related to the effects of a problem-solving based instructional model on achievement and alternative frameworks of the 9th grade Earth Science students in Taiwan. And he graduated with a GPA, which is very remarkable, at 3.83. And he obtained the master's degree in education from Science Education at the University of Texas at Austin, Texas. He achieved a GPA of 3.8 at the first senior high school in Taiwan. And regarding his remarkable professional employment, there are a lot of outstanding achievements and also employment careers that he has achieved, such as the co-editor of International Journal of Educational and Methodology from 2019 up to today. And he is also serving as the guest editor of Journal History of Latin American Education. And of course, he has achieved lots of other employment careers, such as the editorial board member at the British Journal of Educational Technology, editorial board member of Journal of Research and Science Teaching, and also editorial board member at the Journal of Taiwan Normal University. Well, I guess we can go on directly with the presentation by Professor Chang. So Professor Chang, we have 45 minutes to cover the whole discussions, and then we will go on with the question and also answer sessions for 50 minutes.
Okay.
To Professor Chang, time is yours.
All right. So I'm trying to share my PowerPoint. Okay. Hope it works now. All right. So can everybody see the PowerPoint now?
Yes, very clear, Professor.
All right, great. So what I'm going to share with you today, well, by the way, thank you so much for the nice introduction. So what I'm going to share with you today is the idea how to tackle the challenge of COVID-19, like, you know, the similar pandemics, you know, during this time period, like, you know, originally I should fly to Indonesia for, you know, more than 4 times this summer, but however, I'm doing all my virtual keynote, actually in my own study room, okay? Then, so it came to me like, you know, especially, you know, a time like this, maybe we can still help not only teachers, but also students learn through, you know, through this hard time, okay? So I came up to the idea in terms of it, I call it Internet of Teachers and Students, okay? The major idea sort of borrow from Internet of Things, quite, you know, quite, what do you call it, quite famous, okay, popular recently, okay? So the reason I want to propose this Internet of Teachers and students, maybe, you know, like, you know, from one video, I will show the video a little bit.
In 1930, the Republican-controlled House of Representatives, in an effort to alleviate the effects
like, you know,
of the
quite famous video,
anyone,
I think in the
the Great
1970s,
Depression,
professor,
passed
he is like, you know, doing the lecture, and the very, you know, he's like, you know,
the
doing all his
Hawley
best
Smoot
try
Tariff
to
Act,
explain
which
the
anyone raised or
depression,
lowered
okay, big depression. But
raised
however,
tariffs
all the
in an effort
students,
to collect more
they
revenue for the
just
federal government.
like
Did it
totally
work?
lost it.
Anyone know the
Okay,
effects?
so this is
It did not work in the United
so it's been a long time that teachers and students maybe try to see how can we deal with this type of situation. So I transformed the Internet of Things, the popular ideas, into Internet of Teachers and Students. So first of all, I would like to introduce the idea, Internet of Teachers and Students, a time like this. And so one of the tools we developed at my team it's been 5-6 years, 7 years now. So it's called Cloud Classroom, which especially are very useful in time like this. So I would like to do a little bit demo regarding the Cloud Classroom, especially with this virtual presentation, like we have people from all over the world. Okay, then I would like to present several empirical studies, not only in real classroom, but also in online learning and several studies. Okay, and one study is actually a study done by my former doctor student. He's right now going back to Denver, Bevo Wahano, excellent student. So, and I'm going to, if I have time, maybe I can also present a little bit regarding his work using Cloud Classroom. Then finally, I have some thought on how could we move forward. Okay, so the Internet of Things, if you look at the wiki, it's kind of a system, interrelated computer device. They can, they transfer data over a network, okay, without requiring human to human or human to computer interaction, okay? So the most famous idea is like the smart home, okay? So it occurs to me that actually in time like this, so if we have an ecosystem which can actually connecting teachers and students, they can interacting with each other through question posing, answering, responding, collaborative problem solving, and gaming together. So this is the Cloud Classroom, the tool we have been developing for the 7 years. It can not only, of course, originally it's best fit in the real classroom, but now we can also do it online. So I'm going to use this, online with all of you in order to let you to feel a little bit about how can we use this internet of teachers and students, connect everybody together. Of course, if you have this learning environment, as long as you have a device which can access the internet, then you are all connected together. So it can be used in museum, field trip, anything like you want. If you have a device, everyone has one device and access internet. So this is how the Cloud Classroom work. So I'm going to quickly go through Cloud Classroom with you. Okay. Originally there are several video, but because I only have 45 minutes, so I want to skip the video. So the original idea is actually the Cloud Classroom is, they call it a smartphone version of clickers. So like teachers in the real classroom, they give a question, then students if there's a multiple questions, then they give their answers, okay? But however, with the smartphone evolutions, then the clickers, because it costs a fortune, like 4,000 US dollars with maybe 100, the clickers, and also it can only be used in one classroom. Not like right now, I'm going to demo the Cloud Classroom with all of you, okay? So the Cloud Classroom was actually featured in 2018-19 Horizon Report, which is an influential educational technology trend report. So it's actually in the mobile learning category. So it was a category. It was featured as an exemplar institution. Okay, so you can take a look at the 2019 Horizon report, which the Horizon report published every year. You can just download it. It's free online. Okay, so the cloud classroom, we have only like 3 persons working on that. And one engineer, one of my like R&D postdoc, and myself. So I'm the one who is always do the talking. Okay, so to get you familiar with the cloud classroom, okay, as you can see here, you can log in as teacher, as student, or as guest. Okay, so then as a teacher, teachers can actually throw like flyby questions, or they can select question from the quiz. They can download all the activity today. They can manage the classroom. They can even flip the role of student and teacher. For example, I can flip. I can select one student as a teacher at the end of my lecture. Ask he or she to give a question, just like teachers. Okay. So what I want you to do right now is please get down the second because it's close by to your location, so the internet speed will faster. It's called sg-ccr.tw. Okay, so then we have one server in Taiwan, of course, one server in China, and we try to establish more maybe in the future. So in European or in the United States. So it's a no free of charge cross platform. You don't need to download. You just open a browser, then you type sg-ccr.tw. Then we have right now 16 languages. Okay, more than 70,000 students, teachers, and more than 500,000 records. Okay, so you can use your Facebook or Google login. So please, if you are online with me, please log in as a student. Then when you click the student, but if you don't want to with a Facebook or Google, of course you can use guest as well. Doesn't matter. So I will log in as a teacher. Then you log in as a student. Okay, don't log in as a teacher. Okay, because you are going to be my student right now. Okay, so when you log in, please the first after you log in, the first screen will be 100. No, the first screen will be enter the classroom. So please enter 100. Okay. So I haven't seen anybody log in yet. So please log in. Yes, one student. Thank you. Okay. All right. So I got some students log into my cloud classroom 100 now. Okay. So this cloud classroom is actually a highly interactive classroom. As a teacher, I can establish. Okay. I see some students. So please, log in as a student using your Facebook or Google account. Then enter the 100 classroom. Okay. So on the top left screen, you can see a yellow button. You can send me private message, okay? Or you can send me a private message, or you can using the emotion to express how you feel now, like happy face, angry face, weeping face, sleeping face. Okay, so then as a teacher, I can give you a question. Okay, so right now I'm just I just give you a broadcast message to let you see my my message to all of you. Okay, all right. So it's kind of like this. I use a photo just nearby my desk. Okay, so then I send out a broadcast message. Okay, so everybody, if you are online, you can see where I'm located. So of course, you can also send some public question by the students. Okay, so the most public question will be on the top. Okay, so I already, wow, Babel is online. Babel is like messaging me. Okay, Babel, how are you? Okay, hope you are doing very well in Jamber. Okay, all right. So as a teacher could give out different type of question, true, false, multiple choice, open-ended. We also have like animation bank. So I'm gonna show you some animation question as well. Okay. So then as a teacher, if I got a student's responses, I can broadcast students' results. Okay, then you can show all the different things. So it's a very, very powerful tool. Okay, and you are more than welcome to use it. Very recently, okay, this is the latest development after Babel left. So we actually incorporate some AI function in the chat room. Okay, so the AI function is based on the Google BERT and OpenAI GPT-2. So there's a robot. The robot can join the group discussion. If when after you give a student give responses, then you group students into different group so they can do discussion. So we just have the latest model. So right now it's in Chinese only, but of course we try to extend it to other language, in the future. So as you can see here, the Mary 04 is actually the AI robot try to help or make the discussion more fun. Okay, so in Cloud Classroom cannot because the old time clickers can only do multiple choice and also true false, but with smartphone version you can do open-ended and animation. So and also you can do role swapping. Maybe I can later on role swapping. So I'm going to on the Cloud Classroom, I'm going to give you a quick animation so you can experience it a little bit if you are online with me. If not, it's okay. So this is let me see. Okay, so this is kind of like animation. Okay, dust explosion. So on your screen, you are supposed to see the screen on the PowerPoint now. Okay, so then students can actually work on animation. So you can work on yourself. Okay, so of course, and we also collaborate with EU projects called GoLab. So then we have some kind of online collaborative problem solving. Okay, I also want to show you this. I'm going to end the dust explosion. Sorry, I want to let you to experience the seesaw. Okay, the seesaw is kind of like one student on the left hand side and one student on the right hand side. So they try to discuss. Okay, then try to discuss how to balance the seesaw. Okay, so if you are online, you can actually team up with your friend to do that. So if you do a quick discussion in there, then you will see some the robot, the AI robot will also jump in to do discussion with you. But however, it's in Chinese. So unless you type Chinese, otherwise, if it's English, it doesn't work now. Okay, so then recently, last year, actually, it was also featured in Haoran report. We have this gaming feature, which can actually students can get some points, gain points for correct answers. Then they can use these points to buy tool, weapons. Then they can use to answer the next question. So there's a ranking board, so make all the competition more fun. Okay, so after our gaming module was on last year, So like many teachers and students actually are using this in Taiwan. Okay, so if you are interested, you can get to you can just type Cloud Classroom. Okay, we have Facebook and all this. Okay, so the best thing, especially in science, is you can actually use this to examine students' misconception. Okay, so originally I want to use this to give it with you, but right now we don't have too many students online, so I'm gonna jump to how do we use the Cloud Classroom. Okay, especially in Asia, you know, the several empirical studies. Okay, so so I'm going to give you several empirical study example to showing you how to best use this Cloud Classroom. So it's kind of like an internet. So right now, today, I also use this with you. Okay, then the best practice, it doesn't matter online or in the real classroom. You ask questions, then you maybe vote or not vote, or you display student answers. Then you can ask student to do peer discussion, then you vote, or you don't vote, then you do discussion again. Okay, so this is so the past research using the clickers. It's not a smartphone version. It's a clickers. It's by Carl Wieman, the very famous Nobel Prize in physics. So he published a paper in Science in 2011. So it's kind of the study actually showing like, you know, if you use this correctly, okay, you can actually improve students' learning in physics class. Okay, so this is the one snapshot of the results. So as you can see, the control group again, experimental group, you can see after they use these two sections, experimental group are actually, you know, perform a lot better than the students. Okay, oh, this is something for fun. Birthday in the old days, just look at all these presents. Birthday nowadays, look how many people remember me on Facebook. Okay, we also use Facebook for our login. Okay, before, who made the word there? God made the word, my son. Now, who made the word there? Look it up, Google, my son. Okay, so if you want name, but because, you know, we have this smartphone version, then you can actually modify the peer instruction with a Cloud Classroom. You can develop your own way to do that. So one example is like, you know, we use this with using physics, friction and Newton's first law. Okay, then we use this question to ask students. Then after students vote, then we also try to integrating Cloud Classroom with their hands-on activity. Then after this hands-on activity, you see here, then students can actually, we actually can change students' misconception. So this is like, you know, individual vote, then after peer discussion and hands-on experiment, after a hands-on experience. So even they can, like, you know, do better from pre-test to post-test, even several weeks later transfer test. Okay. All right. So in 1960, in 50 years, a lot has changed in school. Okay. So like in 1961, the parents, you know, like scold the kids, but right now it's the other way around. Okay. So this is a man versus TV. Okay. So a very latest study done by myself. Okay. And so I tried, because time like this, like everybody right now stay at home, the school is closed. So how can we use this like a Zoom or this type of a tool, conference tool with Cloud Classroom? Okay, so I had this opportunity to give an online keynote just like this. Okay, in at the end of July. So this was hosted by Beijing Normal University. So I give a lecture. It's kind of like a 1 hour course. I try to show literature review and the research. Okay, so I give two examples of a meta-analysis research done by my excellent student. One is Youda Jian. The other is, of course, Bevo. Okay, he is right now in Denver now. So his study is same in academic advantage in Asian student learning. Okay, so at that time there are 379, not only university students but also professors. So they joined this conference. So I try to experiment conference tour using Cloud Classroom and Zoom, okay, just like right now, okay? As you can see, so during the online speech in Zoom, I give them 2 multiple questions, okay, using the Cloud Classroom. Do you think the integration can enhance teacher-student interaction? Do you like Zoom and the Cloud Classroom interaction instruction? Okay, so here's the results, okay? As you can see here now, like, you know, on the very previous screen, you can see here, there are 379 participants. But however, when they are really into my Cloud Classroom to interact with me, the number has been greatly decreased. I believe it's the same situation here now because everybody maybe just get online, then they do their own things. Okay, at that time, during that lecture, there are more than 150 students. Half of them are still interact with me with the Cloud Classroom. But I did the survey at the end. So there are still 63 participants, okay, with an instant question. So like it's amazing, like more than 98%. They believe like, you know, if we can use Zoom and the CCR correctly, 98% they think, you know, they can increase teacher-student interaction. And more than 90% they like this Zoom things. So students were also asked to comment on their perception on Zoom and the CCR interaction. So they give some, you know, positive feedbacks like this. Of course, there are also some negative feedback, okay? So like, you know, sometimes in the Wi-Fi network, okay? And also, you know, online, different in real classroom. So we can still like, you know, overall, I think it's a quite good experience, okay? So the last example, okay? The empirical study are actually from Bevel's work. It's a magnificent work. So, and also done in Indonesia. So Bevel tried to use Cloud Classroom to teach SSI through STEM education. Okay, I think we already submit this. It's under review, and we actually submit to a very premier journal in our area. Okay, but I don't want to disclose it because I want Bevel to work on it, keep on working to make it happen. Okay, so these are the research questions. Okay, was asked by this study. Okay, so I think I'm going to skip the several things because I want to leave more time for you to ask questions. So if you have more detailed questions, maybe you can ask Bevel. He's right now based in Denver. Okay, so we have experimental design, pre-post test. Okay, 109 junior high school students in this study, and we use the topic is GMO, and we use a 6E model. Okay, so and there's also multiple level assessment. I think this is a feature work done by Bevel. So he actually categorized in 2 different sets of assessment, but and also using some biological term. He called it proximal and distal assessment. So which is excellent. Then we use a Cloud Classroom. This is how the study was done in Indonesia. And you can see like students, they not only using Cloud Classroom, they also do some hands-on activity, just the one I show you. So we actually leverage on the 6E model. So from the multiple level assessment result of the SSI-based instruction, as you can see, we have a very good big effect size on students, not only on the proximal, but also the distal in different, you know, there are 4 different classes. Okay, so it's a very powerful. Okay, and also students' perception, we also did, you know, the perception. So I'm gonna skip this. Okay, all right. So if you are interested, maybe you can ask Bevel. Okay, so so this is like how things have changed when we have this, you know, new digital world. When I was a kid, go to your room. Okay, kids now, they go to your room, they are very happy. Okay, so I quickly go through the internet of teachers and students, how to tackle here now this time like this, the Cloud Classroom. A quick demonstration. and also introduce several empirical studies. And finally, I would like to elaborate how teacher, learner, technology interact together. Then we can make it fit. For example, time like this, we always not only doing the lecture, we always try to find a tool which can complement the teacher, technology, and the learner. We try to make it fit as big as possible. Okay. So although today's lecture, the cloud classroom doesn't work quite well because maybe the internet speed, maybe the participants are not interested, but doesn't matter what it is. It's actually a very good experience for all of us. So in terms of we try to incorporate technology into our learning, be it online or physical class. So we don't try to reinvent the wheel. We thought we are evolving, but we are not evolving. So we always try to make it more diversified. Okay, so that will end my talk, and hope you have comments and questions, and I'm ready for it. Thank you so much.
Thank you so much, Professor Chang, for such a wonderful presentation. Well, we certainly learned a lot from the presentation about especially how the internet has changed our life, and also how internet has changed our students' learning process, especially with the CCR, which is very compatible with the devices we have with the students here in Indonesia. And well, now, ladies and gentlemen, we will invite questions and also comment from the audience. So if you have questions, please ask to Professor Chang directly, or you can also write in the chat box.
Professor Chang.
Hi, Professor Duffy. Nice to see you online. I like your laughing.
Thank you very much.
I still remember.
Finally, we met again.
Yes. Thank you. So I hope next year you could come.
Yes, definitely. And I will send my lecture, my colleges more to Korea to year.
Okay, sure.
So I just wonder something, because in this country also we have use disruptive technology, especially Internet of Things in our classroom.
Yes.
And we use learning management platform like CCR. So it's very very good software, LMS, and also Google Classroom, and even we use direct cloud meeting using Zoom and everything. But the teacher asked a question to us: how do we assess the character? Because when we teach a student, not only a knowledge transfer, but only we should maintain their affection. Is there any new features in CCR for assessing their affection process as well, in terms of okay, thank you.
So that's actually a quite good questions regarding you are talking about the affective domain, right? So
yes,
not only cognitive but also affective, like when teachers, students are in the class, especially for students, how can we evaluate student affective? So in CCR I demo students actually using the emotion to show how they feel during the class, but that's only one small part. But you actually bring a very good point, we try also incorporate more things in order to assess students' affective domain. So in the discussion room, students need to discuss something, right? So right now we are actually involved some robot to interact. Maybe in that way we can also record students' affective domain. But you are right. I think this will be thank you for the great idea. in the future, I think we should, not only looking at the cognitive thing, but also the affective thing is also very important. Thank you so much, Professor David.
Thank you, Professor.
Okay, thank you so much, Professor David. We are still, of course, inviting and waiting for some more questions and comments from the audience, especially to those who are majoring in science education and also science teachers especially, because I do believe with the power of internet and especially of mobile technology, we can involve more students in our learning process and help them to achieve higher learning objective.
So I see some type in Indonesia, I think on the chat room, but I cannot understand it.
Okay, we'll translate the questions for you.
All right, thank you.
You're very welcome, Professor. Well, okay, we have one specific question related to the integration of technology in teaching. Well, the problem in our country, Indonesia, is the technological literacy and also the socioeconomic background of our students. So according to your experience, what are the, let's say, the parameters that we have to take into account before we actually come to the class with the technology in order to make the teaching more successful?
Yes, I think that's a very legitimate and also very good question. Okay, thank you so much for bringing it up. So, technology, educational technology has been in the classroom for long, very, very long. But in in the 1980, Clark from University of Southern California, okay, from USC, he published a paper. It's called "The Media Will Never Change Learning." Very, important seminal work in terms of, he think if we emphasize technology too much, technology is only a tool to get, students from one end to the other end. So you can use your traditional lecture. You can of course add some media, but according to him, he thinks media will never change learning. The reason is he thinks media is only a tool. The real core is how you design your own pedagogy, your teaching, with technology or without technology. To some extent, I actually agree with Clark. If sometimes we emphasize technology too much, many people, when they first encounter technology, think, wow, technology is excellent. We should, use this, we should use that. But however, there's a very major drawback. There's a major drawback you emphasizing too much on technology. For example, in a classroom, teachers can just stand in front of the students. Then they can just start talk. The mouse itself is actually a very good technology, right? In this respect. So if you can do a very good presentation, you don't need all those extra technology. Why? The reason is when it comes to technology, you are right. You need to have some technology literacy. You need to know how to set up the software, how to set up the hardware. Even cloud classroom itself is so easy, but we still have so many teachers refuse to use it because you still add something more. You still make their effort, more effort. So in my opinion, if teachers can teach in his or her class very efficiently without any technology, I think go ahead. I think that's good enough, okay? But however, when you think the technology itself, it's a little bit important. If I can show the video, I can show the animation I show. So which really put, the the science problem in the context, then technology has its own niche. Then maybe at that time you can incorporate some. But when you incorporate some, of course, you need to get familiar with, doesn't matter the hardware, the software, even though it's a small barrier, teachers need to cross that barrier. But if you can cross that barrier, then it's actually quite easy. So of course, we want encourage teachers try to incorporate some, but however, it's not a must. You can adapt yourself, okay? So maybe I think if Bevel is still online, maybe Bevel, are you still online? Maybe you can help me to answer how you use the cloud classroom in Indonesia to give them some, like more contextualized answers. Bevel, are you there? No.
Mr. Bevo, are you here with us?
Oh yeah, Bevo is there. Oh, host my video. Okay, how to host your video? Hey, Bevo.
Hello, Prof.
Hey, Bevo.
Yeah.
Hey, Bevo, nice to see you.
Nice to see you too. Please say hello to all of my friends in Science Education Center, Prof.
Okay.
Yeah, all of my friends in Science Education Center, please say hello to them.
Okay, thank you. So
Yeah.
maybe you can give some comments regarding the technology you use, the CCR you use in Indonesia.
Okay, could you please, could I use Indonesian language to explain a little bit about the CCR that I did in Indonesia? Then they can understand quite easier. Ya, mungkin saya akan menjelaskan sedikit tentang apa yang telah pernah saya lakukan di Indonesia tentang yang Prof. Chang tadi sampaikan di CCR-nya. Saya melakukan penelitian menggunakan CCR itu tentang STEM education, khususnya tentang topik socio-scientific issue yang tadi datanya sudah disampaikan oleh Prof. Chang di layar. Saya melakukannya di Bengkulu. Itu topiknya tadi tentang GMO, genetically modified organism. Nah, di sana itu karena mungkin waktu itu belum pandemi seperti sekarang, jadi internet masih belum terlalu prioritas. Akan tetapi jalannya CCR cukup memuaskan. Kita bisa mengambil data secara mudah di sana. Kita bisa merekam apapun yang terjadi di sana. Dan kita bisa mengkombinasikan di antara virtual, antara apa yang aktif menggunakan CCR dan juga secara hand-on activity seperti yang ada di foto-foto tadi. Kalau misalnya teman-teman ada yang ingin ditanyakan juga tentang CCR maupun apa yang kesulitan pada saat menggunakan CCR dan sebagainya, bisa langsung menghubungi saya di Universitas Jember di pendidikan biologi. Okay, maybe this all, Prof. You can continue your presentation.
Okay, Bevo, thank you so much. Very nice to see you online.
Prof, right now I'm still in revising our paper in GRST.
Okay.
Finish it before the time.
All right, look forward to it. I think it's an excellent paper. I think we need to get into just. Okay. All right, I also see some other question regarding the how to integrate the CCR with Zoom. So actually Zoom, of course, right now it's kind of like 40 minutes for free, and the cloud classroom is actually also free. So if you use Zoom for 40 minutes and the cloud classroom is free, so you can just, like did what I did now. You use Zoom to lecture with your students or, doing your presentation. Then at the same time, you use cloud classroom. My experience integrating those two technology with the Beijing Normal University is quite successful. Like students feel like they were really immersed in the learning environment, interacting with me, not only listening to my lecture, they also listening. I also post questions, they also answer questions. So from that experience, it's actually quite good. So because of the current situation, I'm trying to, you know, do it several times in order to find the base model to integrate both Cloud Classroom and Zoom. Okay. So I don't know if we have more questions because there are some in Indonesia, but I cannot understand. I only understand the one in English. Sorry.
Well, okay. Thank you so much, Professor Chang, and also to Mr. Pepo for sharing the experience on the use of Cloud Classroom. Well, we certainly can have more opportunities and potential to integrate CCR in our science teaching within Indonesian context. And also we have another question, Professor, which is going to be delivered by Mr. Zainur.
Okay. Zainur.
Zainur, yes, Professor Chang.
Hi. Hi, nice to see you.
Thank you, sir. Thank you very much, sir.
How are you doing?
Okay.
Thank you very much, sir.
Hi.
You hear me, sir?
Yes. Yes. Very clearly.
Thank you for the information. CCR, and I use CCR for the learning system on my course, namely
Really?
Technology, Pedagogical, and Content Knowledge. And this is a powerful learning management system. So, and I want to ask some question. How about to integrate it about mathematical formulation in CCR, sir? Because I'm difficult to write the mathematical mathematical formulation, especially about symbol of mathematics, because I'm integration about STEM, science, technology, and engineering and the mathematics, and I'm difficult to write the symbol of mathematics, sir. That is my problem and all of problem in my students, sir. Give me advice, sir.
Right. Right. Well, thank you so much for the question. So actually, we did encounter like a very similar question from like mathematics teachers, and then there's also like English teacher. So I will give you several examples. Like mathematics teacher, they want to use CCR, but they need some formula. But right now the CCR is written in HTML5, so it doesn't have any like a built-in function using the mathematical formula. So unfortunately, so the only thing you can do right now is you write your mathematical formula on a paper, then you ask students or teachers take a picture. So they use that picture. So because you can upload the picture or the photo. So that right now, that's the only way in Cloud Classroom. But then later on, if Cloud Classroom, I mean the HTML5 can add function using mathematical formula, we will add mathematical formula into the Cloud Classroom. So, some English teacher, they are talking about, can we have like a audio, like because they want to know if students pronounce English or, foreign language correctly. So the same thing with the mathematical formula. If in the future, the HTML5 can support the mathematical formula, can support audio file. Right now, we only have video file. So then Cloud Classroom can also, accommodate all these different needs. So I think because CCR has been developed for 7 years now, so we have so many, like you, different teachers, they have different, improvement suggestions. So we always try to, add those functions into Cloud Classroom as possible we can. But however, please wait a little bit. Thank you, Daniel, for your questions.
Thank you, sir, and thank you for your advice, sir. And how about we integrated about the new simulation from the teacher into the Cloud Classroom, sir? And I explored the Cloud Classroom, and I also see the old simulation about the mountain about STEM, and from select animation bank, how we
Yes.
integrated or add new animation, sir. I
Yes.
see 11 simulation, but we can add some simulation, sir.
Yes, the simulation, the animation is actually done by a company in Taiwan. So if you have some ideas, if you have some ideas, so you want to develop the animation, you can send me the ideas. So I can ask the local company to develop that animation. We can work together to make that happen. So, so if you have some like idea, like you think it's a good animation simulation you want to add, please send me email, or you can work with Bevel. Then we can add more animation. No problem. We will support that. Okay. So we definitely need more animation in there. Oh, by the way, the animation, when students are working on the animation, everything is also being recorded. So you can also doing analysis on students, what they are doing for with the animation, what kind of a choice they are doing. So if you have any idea for the simulation, just send me email. We will try to make that happen and and add it into Cloud Classroom.
Yeah. Thank you for your answer, sir. I wanna write email to you and give the information about how about the simulation, and we can continue joint work in my paper, sir.
Yes, that would be great.
Thank you very much, sir.
Thank you so much. Thank you.
Well, okay then. Thank you so much, Mr. Zainur. Well, CCR obviously has a lot to offer, especially not only to the teaching context in Taiwan, but also I think it's going to be across the globe, of course. Right. Well, do we still have more questions from the audience? Okay. If we don't have any more questions or comments from the audience, well, I guess that's all we have time for the second plenary session, which is done by Professor Chang. So, ladies and gentlemen, let's give a big round of applause for our keynote speaker, Professor Chang.
Thank you so much. Yeah, it's great to see all my old friends back in Chamber. So many, old familiar faces.
Yes. Yes. Thank you so much, Professor. It's been a real honor and privilege to have you here in our conference. So, what we can learn from the second plenary session by Professor Chang is how technology can improve our teaching and also how our students live their life, not only within the class, but also beyond the class. Internet and also mobile technology, such as CCR, can obviously set a strong foundation for online interactive learning, especially during pandemic. So we do need to have more effort to integrate technology in our teaching context. And also, like in Indonesian context and also in global context, higher order thinking skill can be one of the most optimistic target for teachers around the globe. And this can be escalated by the use of technology within new environment. So hopefully we can immerse more students in our learning and also teaching context. And of course, internet and also mobile technologies such as CCR can be a very powerful resource and also a tool to improve our research projects. And we have seen so many papers and also publications related to the use of mobile technology and also CCR, some of which have been done by Professor Chang and also Dr. Beppo, which is very inspiring for our science teachers in Indonesian setting. Well, okay, I guess that's all then, the conclusion for our plenary session. Thank you so much.
Thank you.
I'm passing the floor back to the Master of Ceremony.
Thank you. Thank you. Thank you. Thank you. Thank you very much for Professor Chun Yen Chang and David Imamyarta.
The next agenda is awarding presents. It will given to Prof. Chun Yen Chang, represented by Professor Suratno. We would like to invite Prof. Dr. Andes David MSc PhD, SGN, to give token of appreciation for Professor Chun Yen Chang. Please welcome. Please give warm applause.
Thank you so much. Thank you so much. It's my great honor.
The third plenary speaker sessions, we will have Professor David. This session will be led by David Imamyarta as the moderator, and we have 45 minutes for these sessions. Prof. David and David Imamyarta, time is yours.
Well, okay, thank you so much to the Master of Ceremony. Well, ladies and gentlemen, we have undergone the very inspiring and also remarkable two plenary sessions. Now we will go on to another outstanding presentation in our third plenary session. And our plenary session in this session is going to be delivered by Professor Dr. Andes David, MSc PhD. Again, allow me to read the CV of our third plenary speaker. So Professor David achieved his undergraduate study in mathematics education at Jember University in 1992. And then he extended his academic trajectory to the Master of, again, Mathematics at the University of Manchester Institute of Science and Technology in 1998, where he focused on numerical computation. And then he achieved the doctoral degree at the School of Information and Technology and Mathematics Science at the University of Ballarat, Australia in 2007. At the University of Jember, Professor David has served as the head of Mathematics Education Department. And at the moment, he is serving as the Dean of the Faculty of Teacher Training and Education. And of course, in the realm of academic context in research, he has published over 60 papers published at Scopus Index journals. And in Indonesia, he has achieved numerous prestigious awards as a researcher and also scholar, such as the top rank as a researcher in University of Jember as indexed by SINTA. Well, without further ado, we will now hear the presentation by Professor David. Time is yours, Professor.
Thank you very much. Thank you very much. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wasyukurillah, wala haula wala quwata illa billah, amma ba'du. Please allow me to share my slide of my talk.
As Professor Sebastian already presented related to graph theory, combinatorics, and also Professor Chang already presented as well about the educational side, especially in this pandemic era by using learning management system CCR. My talk is a combination between the combinatoric graph theory and also education, but a little bit focused to a student learning outcome in combinatorial, namely combinatorial thinking skill in solving R dynamic phase coloring of tessellation under the application of research-based learning. So we have three keywords here. First one is combinatorial thinking skill, which is a part of the higher order thinking skills. And the other one is graph theory side. It is a content knowledge problem we call R dynamic phase coloring. And the other one is the teaching methodology, teaching method we call research-based learning. So we will discuss within 45 minutes all three terms that we have in this title. I already mentioned and introduced by a moderator. Now we also have initial research in this talk, especially people also initiated introducing research-based learning. So you can go through the internet by Googling. You can type research-based learning and also combinatorial thinking skill and the others are dynamic. So what is the combinatorial thinking skill? In our research of interest, we will focus and study all the time about the combinatorics element. In combinatorics element, we are talking about numbers and also much of the time we are talking about the graph element, which is consisting two elements, namely vertex and edge. The combinatorics itself is an area of mathematics primarily concerned with counting, both as a mean and an end in obtaining result and characterizing a property of finite structure. The well-known founding fathers of combinatorial problem were Pascal, it was a long time ago, Jacob Bernoulli and Leonhard Euler. Now we have a combinatorial problem, especially when we are teaching a student, either in the school level or in the university level. What is a combinatorial problem? The question normally arises, does the solution exist? This is a combinatorial problem. If it is exists, how unique are they? And find also, furthermore, we also want to know how optimum are there. If we can find the optimal one, and then can we generalize it? This is the combinatorial thing. In such a way, it is what also happen for n elements or for more n element. And if we already can generalize, then people also asking, can we prove it? So when we compare with the higher order thinking skill, especially in the 21st century era, so we have kind of the association of those kind of the question mark. So the first question associating with the innovative thinking skill, the second one, creative thinking skill, the third one is critical thinking skill, the fourth one is collaboration skill, and can we prove it mean we can communicate, and then we have a communication thinking skill. So in teaching, not only uh, generalize and obtaining the formula, also we explore the student activities. So that's why we have at least three domain: affective domain, and also cognitive domain, and thinking skill domain. So which is considered all the time when lecturer or teacher teach in the classroom. So there are a lot of combinatorial problem. Professor Sebastian already mentioned before. I just go through into a very simple combinatorial problem. We take two-dimensional sequence. For example, here. So we have table 1, table 2, and table 2, 1C, for example. If we have two-dimensional, indicated by I, that's in the row side, and J is in the column side. When we have three columns and two rows, then we want to start put numbers. Normally we put original number. Yes, natural number 1, 2, 3. Then we have 6. What element there? Because we have three columns and 2 rows. Then we have 6. So how to put 1, 2, 3, 4, 5, 6 in this blank column in such a way the summation in column form an arithmetic sequence. And then we have this kind of formula. We have the first case when we put 1, 2, 3, and the bottom, the second rows we have continue with 4, 5, 6, and finally we add up in the column side 1 plus 4, 5, 2 plus 5, 7, 3 plus 9, and then finally we can have what arithmetic sequence in the what the summation. And table 2, 1b also we have generalization, and table 2, 1, 3. C also we have a generalization, and finally all of them form an arithmetic sequence. So we will go from 1 goes by rows, then we will have a arithmetic sequence. But otherwise we also have a summation, and also we have generalization, not goes by rows, but this type of the arithmetic sequence goes by column. So we start 1 and going down 2, 3, going down further, and again up 5, 6. So the question now, do you have other type of filling the tables such that the summation of the final rows form an arithmetic sequence? It is a combinatorial problem. It is a combinatorial problem. And finally, we will have a lot of cases. We will have a lot of combination. Then students are asked to fill that column in such way they can find the formula such that they have different from each student. It is a combinatorial problem. That's we hope. But when we teach in our classroom, not only asking the student to fill that form, but also exploring their mind activity. We explore also their thinking skill. Then we call here is combinatorial thinking skill. So when we talk about in which level combinatorial thinking skill are, it is actually in the higher order thinking skill level in here. So at least the combinatorial thinking skill student should have analyzing thinking skill, should have evaluating thinking skill, also should have a creating thinking skill. So otherwise, we can consider a lower order thinking skill. So HOTS, higher order thinking skill, is important in now this era because when we talk higher order thinking skill in this disruptive technology era, so the higher order thinking skill, when we talk about analyze, the student or people should have a capability or thinking skill in mind mapping, for example, surveying, linking, validating, grading, testing, posting, not only copying or downloading. It is very low. It is low. It is loads. It is lower order thinking skill. So in this research, normally people in the educational research here, when they have a new learning outcome and then they try to develop the indicator to explore for their subject research. Now we also have developed an indicators. For combinatorial thinking skill indicators, we have 5 indicators. And then we have also sub-indicators. The first indicator is investigating some cases. That is the first indicator of student having a combinatorial thinking skill. The second indicator is recognizing a pattern of all cases and generalizing for all cases, proving the mathematically, and finally they should be able to have a conjecturing another combinatorial problem. So all indicators also split it into sub indicators. Then we have 1A, 2A, 3A, 4A, and 5A. So all these cases are the sub-indicators of the main indicator of combinatorial thinking skill. So this is the first level. So the combinatorial thinking skill could be possessed by a higher order, higher student, higher education student, could be possessed by school level students. So for the teacher who joining this conference also can explore the student combinatorial thinking skill in a school level, because also in school level they teach a combinatoric as well, especially number theory as well as permutation and combination. Now we are talking in school and higher order, in higher education student. So in higher education student, we have discrete mathematics, subject courses, we have graph theory, and we have the application of graph theory. We have many things about the graph in this university especially. Then we introduce about R dynamic coloring. But now case we especially studying R dynamic coloring of tessellation. What do we mean by R dynamic coloring? We mean a proper K coloring C of graph G such that the norm, the absolute of coloring of neighbor of a certain vertex greater than equal minimum R, and also degree of P for each vertex. I don't want to go into further of this kind of the definition. Then what is the condition? All the adjacent vertices must have different color. All color of a vertex neighbor must satisfy this condition. And the R dynamic chromatic number, normally in proper dynamic coloring, we call chromatic number. In this case, we call R dynamic chromatic number should be minimum. This is the condition. But for the elementary example, I can give you the example. This is the graph coloring, dynamic coloring on the example. For example, consider the four-way junctions. Yeah, if you see a four-way junction, for example, in this case we have two roads, yeah, each junction, and sometimes the car from the other side can go through, can pass through without considering the traffic light sign. Then there are a lot of conditions. Sometimes it will be more complicated if we have a tram on the middle of this four-way junction. But unfortunately here there is no trams, yeah, because tram no need to have a light sign, yeah, for example. Then we try to have modeling. But in this case, mathematics modeling, we still normally expressing with the elements. Two elements only needed. The first element is vertex. The second element is a connection, is an edge. Look at this here. If we draw the pattern of the four-way junction, then we can see. So we assign A, B, C, D, F, E, G, H. Then we have 2 times 4 because 2 4 root, and we each root there are 2 sides, 2 side root. Then altogether we have 8 side of root. Then there is a condition that can be expressed there. The path that's going to go through, pass through without any considering the light or the traffic light from B to C. Yeah, the car or motorbike or everything can go past through. And A and D to E, G and F to G and A and H finally to A and C. So the element which is connected to each others, it means they can go past, they can go past through without any considering the light science. Then we can have a graph representation then. So the previously I said that B goes to C and E, and D goes to E. Then BC is a representation, a vertex representation of a graph element. And finally, we have a graph representation such like that. Yeah. So the not accessible route, for example, the car does not allow to go past go through unless they have a green side, a light side. Then we will have a connection by drawing an edge. So in this case, we have 4 edges, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. Then, by means of graph coloring, the 2 adjacent elements, especially the 2 adjacent vertices, cannot be assigned the same color. And finally, we have this kind of coloring. So we have red color, we have green color, we have green in Madura is blue, yeah, blue daun, yeah, and then we have yellow color, yeah. It is color. So we have 4 colors, of course. So how to consider the traffic light sign? And then we have this kind of thing. So by considering the graph, there are traffic light sign are something like this. We can choose the type 1 or the type 2. The type 1, type 2, all everything is okay. Red light sign, DG, HC. And a green light sign, the car or every traffic can goes BE, FA, BC, DE, FG, HE. And for the yellow one is just like notification that's people can read it to go, or you can find you can have the second type of the traffic light. So in the traffic lights now, what happened? So they automatically have a red sign, a yellow sign, green sign, because there is a graph theory scientist there. They develop a programming and they put in their chip, and suddenly they use artificial intelligence. Then they automatically light red, what's light on, and also yellow light on, and also green light on, and everything is automatic because we already assigned by using a graph coloring. Now we have illustration of our definition is a bit more complex about graph coloring that we call R dynamic coloring. So look at this one. This is a proper coloring, which already given there the application on traffic lights problem. This graph coloring consists only three colors, red and green and blue one. So look at the condition. The two adjacent vertices couldn't have the same color. So when we talk about R dynamic, so with the proper K coloring, proper coloring, then R is considered is equal as 1. So in this case, proper coloring is actually part of the R dynamic coloring. For the specific case, R equal 1. So look at the definition and we consider. If we have talking about 1 there, we are talking about 1, and 1 have a neighbors which has two color type. So the type 1 is 2, the second one is then 1. We have 2 here. The number of colors. Number of colors, the other one is 1, number of colors. And then compare with the mathematical condition, minimum 1, 3, of course 1. The minimum 1, 2, of course 1, altogether satisfied. So what happens if we increase R equal 2? And finally, we have a problem now. The second one is not satisfied because minimum 2. Second one is have 2 degrees. Yeah, and also they have 2 type of colors. So minimum R 2 and equal to. Not okay. So we should have a permutation again of assigning the color, and maybe it is not enough to have 2, 3 colors. Maybe we need to have more colors. So that's why R dynamic. So we have R2, and finally we have 1, 2, 3, 4. Need 4 colors. Not enough for 3 colors. But for proper coloring, we have 4 or 3 colors. So again, we can increase R equal 3. We increase also R equal 4 until R equal K. So that's we call R coloring. So the parameter goes from 1, 2, 3, 4 until K. Whatever K, such that we can finish and we can satisfy the condition. So this is R equal to. And then chromatic number for R dynamic is 4. But for R equal 3, it is not satisfied again. We have a problem again with the color 3. Yeah, because the neighbor has 2 colors, and for the condition, minimum 3, 3 is also 3. It is not okay. So that's why we need more colors. So now by proposing this problem to a student, it is very not easy. A student deal with this problem, but by using research-based learning methods, we try to a student, yeah, all the time in my subject courses, and we get a success. The student can have a success even not in the research student level. So this is the main thing. We try this one in the classroom. Normally people try this one and study this one with the research members in the research group. But in this case, by using research-based learning, we try to bring our problem into a classroom and inserting our open problem into a classroom, ask our student in a classroom to do the same thing that we done and we working in the research group member. But we need to have a research-based learning. What is the research-based learning element? Actually, we have three elements here. Of course, lecturer and a classroom and research group. So we have any this one, then we couldn't do a research-based learning. By having a research group, then we can have research group member to come to our classroom. Actually, it is quite similar with lesson study. And lesson study, there is open lesson in the lesson study, and they invite some lecturer come. But in this research group, when we invite our lecturer, they are a research member of our research group, and they are not only observing the student activity, they are a tutor. They give a tutorial in the classroom. So maybe this is the difference. And we are working together to solve the student problem, especially in the R dynamic problem. So there are a lot of triple helix relation between a lecturer, classroom, and a research group. What is the research group and lecturer? What role? Thesis, dissertation, and joint research supervision. And lecturer come to a classroom, bring their unsolved problem, open problem, and the class and the research group. And classroom are encouraged to have initial solution for the specific open problem that it is very complex to solve so far. So this is the main thing. So we develop this research group syntaxis because this is a part of our also care and research. Yeah. So not a project-based learning, not also discovery-based learning, but we call a research-based learning. So actually, it is already done by Blackmore and P. and Fraser in 2010, but we developed this one. The integration of research into learning process, Haley already introduced it to 2013. What is the research-based learning there? Yeah, there are two quadrants. The first quadrant is research-oriented, research-led, and research-tutored, and research-based learning in a fourth quadrant. So in research-based learning process actively involves students to do research in solving problem arising from RG open problem. So it is a little bit going right, and for the what emphasis on research content, a little bit going left. So research-based learning activity actually motivate the student to solve a research problem, not on textbook problem. Textbook problem, yeah, can be taught in the low level, higher or education maybe, but for the advanced subject courses, we take the research-based learning into a classroom. So this is the difference between research-based learning and project-based learning. Look at here and cognitive level, applicative, critical, and research-based learning. And for the aspect, cognitive level, critical, and creative. For the problem, project-based learning normally routine, but in research-based learning, non-routine. The problem solving in the project-based learning is procedural, and research-based learning is non-procedural. So we have open-ended problem, yeah, multi-technique and multi-solution. The scope problem arises from a class, but research-based learning problem arises from the RG research of interest. So that's why establishment of the RG research group in the study program is important to set up first. And finally, we can implement the research group, research-based learning into a classroom. Otherwise, we couldn't implement this one because the problem that can be solved in the classroom, the problem that can be brought into a classroom arising from the research group open problem. Student status in a class, students are considered as a student who are joining a classroom. But in research-based learning, students are considered a researcher who are joining a classroom. So that's why if they can finish the research project, for example, the research-based learning project, if it is potential to develop into a manuscript of a paper, the student in a classroom could be an author, could be a co-author in the paper as well. So it is our process that we can have, so that we have so far, such that our publication is getting bigger and bigger time to time. Method, decide, final decision, the research level, yeah, not necessarily new, and research-based learning should be new, even though it is very simple one. So a bit different, yeah, a big difference. There is a big difference, not a bit different, but big difference between project-based learning and research. But the collaboration between a team is similar with a lesson study. You have a team teaching, but we have research group member as a team teaching there, not like a normal team teaching. So by carrying this study, starting from 2017, we have what starting this study. The first study we also already published in the international journal, namely Journal of Instruction, International Journal of Instruction. It is now the quartile is Q2, and also we published in the HRPAP. It is also a journal of Q3. Then we start to disseminate this the syntaxes of research-based learning. And finally, the our institution, the Center of Excellence, IDB, yeah, and CDAS adopt this research-based learning. And the rector 2018 consider and develop a new rule, a new article, a new rector rule, and the rector consider the development, the establishment of research group in this university and implementing research-based learning in the classroom, especially in the University of Jember. This is our syntaxes. Normally, not only this one in the classroom, and finally also we bring the research group, the research project into research group members. So we have a syntaxes. Having the syntaxes and also having the learning outcome, having also the the problem are dynamic. Then we have finally studied the learning, the thinking activities of the student, especially in solving our dynamic phase coloring of tessellation. What is a tessellation? This is a tessellation. From Q, this is tessellation. Yeah, when you have a break, normally they are colorful break. Normally you set up the break in the backyard or the front yard of your houses, for example. How have to have a good coloring design, for example, need to have a construction of colors. When you construct the color by using randomly technique, then you have a very, very simple thing. Maybe the other construction could be similar from the previous construction. But by using a graph theory, especially R dynamic coloring, when we have this kind of a breaks, yeah, for example, tessellation, then you have this kind of thing. For example, what is the principle? This is part of the planar graph in our study. So when we are talking about planar graph, when there is a face side to side with the other face, then we draw a line. The face represents one vertex, and the connection, the line represents the face are side to side. So for example, this case, yeah, the first face, this one, the second face, and the third. We draw a line because they are border here. Yeah. Okay. Then finally we have a graph representation. This is actually dual tessellation, and it is a graph because that consists only two vertices, two elements, vertices and edges. And finally, we assign label. We assign color. Color means assigning color to a vertex. This is called vertex coloring. But in this case, not only R equal 1, which is it is proper coloring, but we consider R equal 2. So, but the condition, the two adjacent vertices couldn't have a same color. Look at this one, R and G. Yeah, R, G. So, because the two vertices here are adjacent, then we couldn't have two same color. Red, green. Again, red, blue. We couldn't have green here, which is conflict with this one because we already have G, and then we have B. It is G only, okay, because there is no connection with it. Yeah. So finally, we have four colors. 1, 2, 3, eyes. Three colors, not four colors. Then we have this one again. Color the graph by R equal 1. This is proper coloring. But we can improve our R equal to. Then we can again get back to the tessellation. And how is tessellation color now look like? It just look like this. So when people, the tessellation, we put the brick in your backyard or your front yard, by using a graph coloring, then you have a more beautiful combination of the tessellation because we are using a graph. Then we have permutation, we have a lot of construction of R equal 1. So this one consider 1 to R dynamic coloring of tessellation. Then finally, you have this one. Yeah, if you put together, you have this one, you have this one. It is not allowed because there are two sides, faces has the same color. And you put the other way around, then you can have another. It is not allowed because it is contradiction with the condition that we have given now. No, this is good, not good. So how is good then? Okay, now we have this one. So put the assignment just like the R equal dynamic coloring. But when you place the construction, instead of the having what goes from by rows and just go by color. Then you have this one, this one, this one. Then finally you have a good coloring. This is yes. So you can set up your break, the break in your backyard or front yard by using R dynamic. But our study is not focused to this case. Our study is focused how student creative thinking process, combinatorial thinking process, when they put and they place the break, the tessellation based on the R dynamic coloring. This one is secret. It is by using this one. And finally, we have this case. I believe this one is not something that we want to talk. And finally, we have also a portrait face of the student combinatorial thinking. And student can draw the thinking process of combinatorial thinking process can be drawn as a graph as well. And finally, we can add up also the statistic descriptive to know the position of the percentage of the accumulation of the criteria of combinatorial thinking. And finally, we have a conclusion. So what is the conclusion? The implementation of research-based learning can improve student combinatorial thinking skill. A various type of graph representation of student combinatorial thinking skill portrait face indicate how differ their individual thinking skill in solving R dynamic phase current of tessellation. But still we have a problem. What is the problem? Especially in the content knowledge problem. The content problem here is R dynamic coloring. Need to determine R dynamic coloring for phase coloring of tessellation of different type of geometrical shape, as well as analyzing the student combinatorial thinking skill by using portrait face, and apply scientific approach learning to improve their combinatorial thinking skill, especially in solving our dynamic phase color. I believe that's all. Hopefully we can discuss and maybe we can have a joint research for the future. Thank you very much. And I give it back to moderator.
Well, okay, thank you so much, Professor Davik, for such a wonderful presentation. Well, we can certainly learn a lot from the concepts and implementation of graph theory, not only in daily life, but also in teaching context. Okay, ladies and gentlemen, we will now open the next QA sessions. We still have more or less 15 minutes. So yes, we are now opening the sessions. To those of you who would like to raise questions, please direct your questions directly to Professor Davik. Or you can also write your questions in the chat box. We will read it for you.
I just see in the chat room, maybe someone who understand what I'm saying, I'm presenting, and someone maybe need to have more about study about this kind of type of study, especially in combinatorial thinking skill, which is considered as a higher order thinking skill. I'll give concluding remarks. So when we are teaching now, not only transferring our knowledge in terms of cognitive domain, also we should consider the thinking process of student. And in this now the era, we should consider what's higher order thinking skill. In the 21st century skill, we need to consider 4C. The first C is creative innovation. The second C is critical thinking, collaboration, and communication. And this in the pandemic era, I believe it will be very hard to have this kind perfect. So hopefully we still keep this kind of learning outcome target. Even we use Zoom cloud meeting, we use a big blue button, and also we use LMS and everything. We need to explore the student thinking skill. So that's why when we use a Zoom cloud meeting, whatever in the classroom, we need to give an effort to say, to interact with the student effectively. So that's why we can, therefore we can have student combinatorial, student higher order thinking skill. So we need to maintain that one. So the second one, when we study about educational side, not only study about how to elaborate the learning model, or for example, the teaching methodology, no, also we should focus also on the content problem. The problem should be problematic. The problems shouldn't be done procedurally, because if the problem can be solved procedurally, it is not a problem. It should be complex. Even in our graph theory side perspective, the problem cannot be solved by polynomial time. The problem cannot be solved in the 1 month, 2 months, or 3 months, for example. Even the problem, in our case, it is NP complete, non-polynomial time. So that's why, as a student, by using open-ended test, which consists to multi-techniques and also multi-solution. Hopefully, my talk is benefiting to all of you. Then maybe we can potentially have a joint research in the future if you would like to do so. Thank you very much. And Assalamualaikum warahmatullahi wabarakatuh. I'll give it back to moderator.
Well, okay, thank you so much, Professor David, for the wonderful presentation. As we can see from the presentation, the possibility of research group is very exponential. We can have lots of opportunities to improve our teaching, and also in educational setting, we can help our students to become researchers, not only in undergraduate level, but also graduate level. And I do believe that that kind of engagement can help students to become engaged both effectively, but also cognitively. So with the research group setting, with the research resources, research process, and also research outcome, we can see that this approach is fundamentally changing our study, like from research, by research, for research. Well, again, ladies and gentlemen, let's give a big applause for Professor David as our keynote speaker. Well, thank you. I'm passing the time back to the Master of Ceremony.
Okay, thank you. The next agenda is awarding presents. We would like to invite Prof. Suratno to give token of appreciation for Professor David. Please welcome. Please give applause.
Thank you very much for all of the speakers. Hopefully, we get a new knowledge and new inspiration so that we can create some papers with a great quality. Ladies and gentlemen, the plenary session for today has been done. For participants, link certificate will be given at Sunday. So please stay tuned till the end of Second EcoSTEM 2020.
Sesi para plenary session sudah berakhir. Untuk link kehadiran bisa didapatkan esok hari, karena besok masih ada kelanjutan dari konferensi hari ini. Selanjutnya, sesaat lagi kita akan istirahat. Kemudian nanti jam 12 kita akan kembali lagi ke sini. Dan saya kembali mengingatkan untuk mengganti nama Zoom-nya menjadi nama yang sesuai dengan yang dibagikan panitia, terutama untuk yang paper presentation. Contoh, apabila Bapak atau Ibu berada di room 1, maka minta tolong kami mohon supaya Bapak Ibu mengganti namanya menjadi room 1 spasi nama Bapak Ibu, supaya nanti kami akan bisa membagi ke kelas kecil di Zoom-nya. Demikian, terima kasih, sampai jumpa nanti jam 12.
This is the end of this session. Thank you very much for your attention. Forgive us if there are any mistakes. Wassalamualaikum warahmatullahi wabarakatuh. See you in parallel session and see you tomorrow.